Well, now we're on section 4.3 and we're doing question 1. So the first part of this question is, what are the critical points of f? Well, what are the values of x that take this derivative to 0? And they are CP x equals 0 and 1. B, it says on what intervals is f increasing and decreasing? So let's draw a number line, and we have a hash mark at 0, a hash mark at 1, and we'll sign this graph. And if x is negative, that'll be negative, that'll be negative. We have the product of two factors that are negative, so we get a positive. If x is something like 1/2, which is in this interval, we'll get a positive, and 1/2 minus 1 is negative, so the product of unlike signs is negative. And finally, if x is greater than 1, we'll have positive. Okay, so it's decreasing and increasing, and it's easy to pick off the interval over which it's decreasing. It's decreasing from 0 to 1. It's increasing from negative infinity to 0, union with 1 to infinity. So let's see about C. It says, at what points, if any, does f assume a local max or min? So, C, and a local min and local max Okay, well notice, as we approach 0, we're going uphill, and if we as we leave 0, the slope is downhill, so 0 must be a max. So at x equals 0, we must have a max, a local max, by the way. And now look what's going on at 1. You're going downhill. It's negative. We're going downhill to 1, and when we leave this value, we're going uphill because it's positive. So we must have a local min at x equals 1. And we've answered all 3 questions. Okay, given this function of 14, or this derivative in 14, we have to find the critical points of f. So we have to find the values of x that take this factor to 0 and the values of x that take this factor to 0. So let's set this factor equal to 0 equals 0. Now we'll subtract cosine of x from both sides, so we get sine of x equals negative cosine of x. Now if we divide both sides by cosine of x, we get sine of x over cosine of x equals negative 1. This means tangent of x equals negative 1. Well, and by the way, we're on the interval, 0 is less than or equal to x, which is less than or equal to 2 pi. Will you agree the tangent of x equals negative 1 at, and I'll draw a circle here. Tangent of x is negative in this quadrant, and it's negative in this quadrant, and it's going to be a multiple of pi over 4, so this is 3 pi over 4, 4 pi, 5 pi, 6 pi, 7 pi over 4. So x equals 3 pi over 4, or 7 pi over 4. So there we've done part of it. Now let's set this factor equal to 0, and we get sine of x minus cosine of x equals 0. So sine of x equals cosine of x. Dividing through by cosine of x, we get sine of x over cosine of x equals 1. This is so the tangent of x equals 1, and that occurs at pi over 4 and 5 pi over 4. So now the critical points are x equals pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. Now, hold on to that. We're going to do, and this was part A, we're going to do part B. So, and we've got an equal sign, and this is a 2. And so for part B, it wants to know on what intervals is f increasing and what intervals is it decreasing. So we'll draw the number line from 0 to pi. And so this is going to be pi right here, pi. This will be pi over 2. This will be 3 pi over 2. Now our zeros occurred at, and I'm going to do it, this is pi over 4. So we've got an interval here from 0 to pi over 4. Then our next 0 was at 3 pi over 4. So we've got an interval from here to here. Now our next 0 was at 5 pi over 4. And finally, so we've got bounds of intervals. And finally, we had another 0 at 7 pi over 4. Now, if you examine, let's pick a value in this interval. How about pi over 6? And we've got a value in this interval, it's pi over 2. We've got a value in this interval, it's pi. We've got a value in this interval, 3 pi over 2. Let's pick a value in this interval. And that's going to be 11 pi over 6. So I'll circle, just to keep track of this, I'll circle our zeros. There. Circle the zeros. Now, if you evaluate this product for x equals pi over 6, what you're going to get is this interval, all the values are negative. You just have to try one point. In this interval, you're going to get positives. In this interval, so I'll leave you to do that, you're going to get negatives. In this interval, you're going to get positives. And finally, in this interval here, you're going to get negatives. So I'll leave it to you to explore that. And we said these were negative, yeah. Okay, so let's see, what did it want us to do? On what intervals is f increasing, what intervals is it decreasing? So it's decreasing and increasing. It's decreasing on the negatives, so that's going to be 0 to pi over 4, union with, let's see, 3 pi over 4 to 5 pi over 4, union with, and finally 7 pi over 4 to 2 pi. And it's increasing. Maybe I can do it here. Increasing on the interval. We're going to pick off the pluses. Pi over 4 to 3 pi over 4, in union with, and the other plus interval is, the bounds are 5 pi over 4 to 7 pi over 4. So those are the intervals on which it's increasing. Now our last question, C, is at what points, if any, is F assuming a local max or min? So let's do this. And so local min, local max. And so x equals. Now notice, as you approach pi over 4, you're negative, so you're going downhill, and when you leave pi over 4, you're going uphill. So pi over 4 must be a minimum. Do we have any other minimums? Yeah. As you approach 5 pi over 4, you're going downhill. As you leave, you're going uphill. So 5 pi over 4 must be a minimum. And finally, we can include 2 pi because it's an endpoint, can't be local. So now let's go to the maxes. Notice as you approach 3 pi over 4, you're going uphill. As you leave, you're going downhill, by the sign. So x equals 3 pi over 4. And also when you approach 7 pi over 4, you're going uphill, and then because it's positive, and downhill on the other side of 7 pi over 4 because the signs are negative. So these are the local maxes, or local mins. These are the local maxes, and we're done.